the time has come to actually start talking about IP routing. So when we talk about IP routing for the purposes of the CCIE routing and switching exam, basically what we care about are some of the protocol independent features, and these are things like the admin distance, the network statement, which kind of is protocol dependent, but still I like to talk about it from a protocol independent point of view. We are going to talk about the passive interface concept. And then of course we are going to talk about different routing protocols. And here, well, protocols, again, with an asterisk there. We're going to talk about the connected routes. We're going to talk about static routes. We're going to talk about RIP, EIGRP, OSPF, and of course, BGP. Even though I like to talk about BGP separately from the others, because it is kind of a special world in its own, and I like to actually think of BGP as not being actually a routing protocol. I like to think of it more of a policy implementation protocol. So let's start this over. Now, the first thing that I'm going to talk about is the administrative distance. Now, we all know what the admin distance is. It's a tiebreaker. I really need to work on my handwriting. Hold on a second. It's a tiebreaker between routing sources. So if we have on one router, or let's do that properly, the routers are always round. So if we have a router, and this router here has multiple sources of routing information, so the information is coming from multiple protocols. And let's say that from all of these sources, we are learning the same route, let's say 192.168.0.0/16. This router somehow needs to figure out which one of these sources is more preferred than the others. So this is where the admin distance is going to be the tiebreaker before this router can actually install the route from one of these sources into the routing table. Now, the important thing to note here is that the admin distance will be used only in situation when you have the route coming from different sources of routing. It will never be used as a tiebreaker inside the routing protocol. So for example, inside OSPF, inside a single OSPF process, if you have the same route learned from multiple sources, and if you try to modify the admin distance of one or the other, you're actually modifying the admin distance at this point here, after the protocol has actually sent the route to the routing table. You cannot use the admin distance to influence the decision made by the protocol itself. The reason for this is that the admin distance is a vendor proprietary concept. Cisco calls it the admin distance, HP, Dell, and others are calling it the admin distance, Juniper is calling it the routing preference, but it's really the same concept. It's the preference given to a particular routing source, but not the influencer inside the routing protocol itself, because the routing protocols are usually defined in standard documents, like for example RFCs or Cisco internal documents that specify how EIGRP behaves, or nowadays actually the RFC that specifies how EIGRP behaves, because it is, well, since relatively recently a standards-based protocol. Surprise. Now, different routing sources in Cisco iOS have different routing preference given. So for example, the most preferred routes are of course the connected routes. Now the connected routes have the admin distance of 0, and this is not something that can be changed. So this is something that is fixed. Static routes are by default the second most preferred routing source, and they have the admin distance of 1, and this can actually be changed. Now, the next preferred routing source are EIGRP summary routes. And these have admin distance of 5. This also can be changed. So let me talk a little bit about this EIGRP summary route, because this is one thing that I have seen my students from time to time have little confusion about. So to do this, I'm just going to use 2 routers in my mix. I'm going to have R2 directly connected to R5. Now R5 here will have a loopback interface 5555/32, and the link here, this is serial 0 to 0, and this is serial 0 to 0, and the link here between them is going to be 192.168.25.0. Let me just very quickly configure EIGRP25 between these 2 devices. So I'm going to go to my R2 and R5. Now I do have some other interfaces configured right now, so I'm quickly going to remove those interfaces. So default interface serial 000, and on R2 no interface loopback 0. So interface loopback 0, IP address 5555. And if I do show IP route connected, I should be seeing this was already pre-configured, so I should be able to ping 25.2. So this is already in place. So the next thing I'm going to do is I'm just going to quickly bring my text editor here, and I'm going to say router EIGRP25 no auto summary network. I want to run EIGRP really on all of the interfaces. This is just going to be a very quick exercise, because the point here is not about the EIGRP configuration. The point here is to show you the EIGRP summary. So if I do show IP route EIGRP now on R2, I'm seeing this 5555 with the admin distance of 90. So this is the default admin distance for EIGRP. So maybe I should actually just add it here. So for EIGRP, the admin distance, EIGRP internal routes, they have admin distance of 90. This also can be changed using the configuration. So now what I'm going to do is I'm going to configure on this interface here EIGRP summary to summarize 5000/8. So I'm going to go to my router R5, and on the interface serial 020, I'm going to say IP EIGRP. Okay, sorry. IP summary address EIGRP 25.5.0.0.0, like this. And here at the end, what I can do is I can specify the administrative distance for this summary. But if I press enter, the administrative distance for this summary will be 5. Now, after my routers have actually reset, if I go to R2 and if I do show IP route EIGRP, I will be seeing this summary. But take a look at the admin distance. The admin distance on this route is still 90. So where is this admin distance of 5 that we were talking about? Well, for that, we actually have to take a look at R5. So on R5, if I do show IP route EIGRP, take a look at this. Now on R5, on the router on which I have actually created this summary, so the result of this command is this EIGRP route on R5. Take a look what is the exit interface for it. It is null 0. So this route here, also called the discard route, has been installed as the result of me creating the summary route. So here at the end, I didn't type this 5. I just pressed enter after EIGRP summary address, IP summary address EIGRP 25.5/8. This is where I pressed enter, but iOS installs this 5 by default. So the result of this summary address is this discard route that is installed on R5 as the EIGRP route in R5's routing table. Now, what is the purpose of this route? Let me briefly try to explain. Now, when we create a summary address, so let's expand our example. Let's say that I have R2 here, and let's say that I have R5, and let's say that instead of having a loopback interface, I may have some interface here that has multiple routers, multiple devices. And let's say that this network here, this router here was advertising 5500/24. This one here was advertising 5510/24. This one here was advertising 5030/24, etc. Now, when all these routes were actually received by R5, I would have any number of these /24 routes. Now, what I want to do here from R5, I want to tell R2, hey, you know what? If you have any traffic that goes to 50/8, send it to me. So let's now say that R2 sends the traffic for 5/17/1931. Okay? So something that we don't have here in this network. Now, when this traffic actually arrives to R5 as the result of this route, because R2 doesn't know any better, R5 is going to say, okay, I'm having traffic for 5/17/1931. Do I have a more specific route where to send this traffic? No, I don't. So R5 is actually going to drop this traffic as the result of this null route. Now imagine that R2 here was actually the router that is connected to the internet. Now, in that case, it is perfectly conceivable that R5 actually has a static, for example, default route pointing to R2. Now, if we had that situation and if we didn't have this null route installed, this route that will cause the traffic to be dropped here, let's take a look at what would be the situation then. So I'm going to go to my terminal, and on R5, I'm going to say that, you know what, R2 is your default gateway to the internet. So this is the situation with the discard route. So let's go to R2 and let's try to ping 5/17, what was the address? 1931. So I'm trying to ping it, and obviously I don't have the path to it. I see the time getting destination unreachable. So if I do trace route to this destination, I will see that traffic takes me to R5, and then R5 actually drops this traffic. That's exactly what I wanted to have. Now, let's on R5 get rid of the discard route. So what I'm going to do here is I'm going to go into the sub-interface mode, and I'm going to install the same EIGRP summary, except that now I'm going to give it the admin distance of 255. Now, admin distance 255, so let me put it here, and I'm going to put it all the way at the end. Admin 255 is an untrusted source, and this is a fixed value, and this simply means that the routes that have the admin distance of 255 will not be installed in the routing table. So now let's take a look what will happen when I get rid of the discard route. So the discard route is now gone, so if I do show IP route, it most likely isn't gone, but I know how to get rid of it. So do clear IP route star. So I'm just going to get rid of it now. So if I do show IP route EIGRP, now the discard route is no longer in the routing table. So from R2, I'm going to try to ping 5/17/1931, and you can see the time now getting slightly different result. It may not be immediately obvious, but this is very, very different result. Because take a look at here. In this case, I was actually getting ICMP unreachables. Here, the traffic simply doesn't seem to get to its destination. If I do a trace route, this is why. Because what is happening now is R2 is sending the traffic following the summary. Then R5 says, oh, this is traffic for 5/17/1931. I don't have more specific route for it, I do have the route for it. Look, it's the default route pointing to R2. So traffic now goes to R2. And then R2 says, oh, but this is traffic for 5000/8, and sends it to R5, and repeat until the TTL expires. The default TTL for trace routes is 30, so we will not go more than 30 hops, but theoretically this could circle between R2 and R5 up to 255 times. So this is what the discard route is trying to prevent to do. Whenever we are summarizing IP information like we've done here, what we are doing is we are losing information. We are losing the granularity of the information. So we somehow need to provide for the loop prevention in this case. So this is what the discard route does. So let me put it back in because it is actually a very useful thing to have. So I'm going to put it back in and I'm going to have it with the admin distance of 5. So if I do show IP route EIGRP, I have this route. Let's go back to pinging this address now. Now when I ping it, I'm getting these ICMP unreachables. Now these ICMP unreachables are sent by R5 when it needs to drop the traffic as the result of sending this traffic to null zero interface. Now if you're receiving a lot of this traffic that needs to be discarded, that can put additional strain and load on R5, and incidentally this is something that they may ask you to address in the lab. So the question that they could ask you in the lab along these lines would be, make sure that when R5 discards the traffic that follows the summary, that you are discarding this traffic without sending the IP unreachable traffic, or IP ICMP unreachable. So the question here is, where would you put IP ICMP unreachables? Well, let's try putting them on the serial interface. So no IP ICMP unreachables. Hold on, what am I doing wrong? No IP unreachables, sorry. So when I originally started saying no IP unreachables, I was actually thinking about the iOS command. But what this is sending is, this is disabling sending ICMP unreachables. You know, sometimes there is disconnect in my head between what the features actually are and what the iOS command is. Well, actually not disconnect in my head, disconnect in iOS, but I digress. So let's try to ping now. Let's see what happens now. See, the ICMP unreachables are now not being sent. But what if R5 had multiple interfaces here? What if I had many interfaces? Where would I enable IP ICMP unreachables? I would have to do it on every single interface. There is actually a more efficient way to do this. So I'm going to go and re-enable IP ICMP unreachable. So now I'm getting them. And on R5, instead of configuring the serial interface, I'm actually going to configure interface null zero. Now, on interface null zero, there is surprisingly little you can do. Pretty much the only thing that you can do is no IP unreachables. So now when I try to ping, I'm not going to be getting IP unreachables, and I don't actually have to worry on which one of these interfaces I have enabled it, because I have actually enabled it on the discard interface, on the interface that will be dropping the traffic. This is where I am preventing the IP and ICMP unreachables from being sent from. So this is what I wanted to show you when it comes to admin distance 5. Now, this functionality here, so I'm just going to write it, is called discard route. Now, discard route is automatically created by EIGRP whenever you create a summary. It's automatically created by OSPF when you create the summary, and is automatically created by BGP when you create the aggregate address. Now, if you want to get rid of it in EIGRP, it would be admin distance of 255 on summary. In OSPF, it will be no discard route under the OSPF process, and for BGP, sorry, you will always have it. So you cannot disable it for the aggregate address that is created. Now, keep in mind that there is a notable absence of RIP. RIP does not create a discard route when it creates summary. So this problem with the default route and the summary that we had between R2 and R5 on RIP is something that is unfortunately the fact of life. So it is not something that you can fix with RIP. Well, you can manually. You could add the static route that points to null zero for the summary, but in the CCIE lab, I want you to have this mental picture. When you type IP route something, there is a piano falling on your head, just like in the cartoons. So you type IP route and bang, you are gone, right? So don't type static routes in the CCIE lab unless you are very explicitly allowed to use the static routes. Generally speaking, they are not allowed in the CCIE lab. So let's go back to this thing here. The next best admin distance that you care about is, of course, going to be OSPF internal routes, which are going to have the admin distance of 110, and of course, this can be modified. Then the next thing that you care about is going to be RIP with 120, and this of course also can be changed. Then we have EIGRP external routes with 170, and this of course can be changed. And finally, we have BGP externals. Oh, I forgot the BGP externals. Missed those. So I'll have to go back and fix that. But anyways, so BGP internal routes with admin distance of 200. So let's fix that missing BGP. They're actually right here. So we have BGP external routes. I knew there was something missing there, just wasn't thinking straight. It's 20, and of course it can be modified. Now, there is one here that you don't really care about, but I'm going to write it anyways. It is ISIS, is sitting between OSPF and RIP with 115, and of course it can be modified, but because you don't have ISIS on your lab, or ISIS as I like to call it, because you don't have ISIS, you don't really care about this. Now, this table, these values, is something that you should really know when you go to the CCIE lab. Mostly because this is really the CCNA level admin distance. So let's bring up the pace a little bit. Let's talk a little bit more about admin distance, about, I would like to say, the CCNP level of admin distance. Now, let's say that we have a router here, and that we are learning, so we are going to be learning the same route. So this is 192.168.0.0/16. So I'm going to be learning this route from two sources. Let's say that this is RIP, which has the admin distance of 120, and this here is OSPF. And this one has admin distance 120 as well. Now, mind you, 120, isn't OSPF 110? Well, yes it is, but we said that this value can actually be changed. So I have modified the admin distance of OSPF in my case to be 120 to make it the same as RIP. So I'm receiving this same route with admin distance of 120 and admin distance of 120. And let's say that the metric here was 5 and that the metric here was 200. Which one do you think will be installed in the routing table? Now, if your answer is RIP, please think again, because metrics cannot be compared in this case. The only thing that matters is the admin distance. But admin distance is the same. Does this mean that we are going to load balance between these routes? There can be no load balancing between the traffic, for the traffic coming from two different sources. So what we need to do here is to choose which one of these 192.168.0.16 is the best. This is where the original admin distance will be compared. The original hard-coded admin distance. For RIP, this is 120, and for OSPF, this is 110. So based on this value, the original admin distance, or the default, or the hard-coded, call it whatever you want to call it. I like to call it the original, but sometimes that confuses people, so here I'm going to give you what I actually mean by that. Based on this information, the OSPF route will actually win, even though on face value their admin distances were the same. So this is easy enough. So if the actual, let's call it the operational admin distance is the same, the original, the hard-coded admin distance will be used as a tiebreaker. But sometimes, in some cases, this is not actually going to work. Now, what is this case going to be? So let's say that we have a router. Again, we have a router here, and we have a route, again, the same route, 192.168.0.0/16, that is learned from two sources. And let's say that this here is OSPF process 1, and this here is OSPF process 2. Now, the admin distance here is 110. The admin distance here is 110. Let's say that the metric here is 100, and that the metric here is 200. So which one do you think wins? Now, if your answer here was OSPF 1, think again. You may or may not be right. Again, the metrics cannot be compared. Why? Because these are two completely separate routing processes. Now, think about it this way, and this is a joke that I always like to do in my classes. So, if metrics of OSPF 1 and OSPF 2 can be compared, I am now sitting in the United States of America, where generally accepted official language, even though technically speaking it's not the official language, is English language. So I am speaking some version of English to you. Now, English means it comes from England, and England has a queen. So given the fact that we are speaking the same language here in the United States as they speak there in England, that means that there is a Queen of United States, and her name is Queen Elizabeth II, the Queen of United States. Well, obviously there is not any truth there in there, unless you of course ask somebody from England, and I'm looking at you, you know who you are, who may disagree with this statement. But there is this tiny little thing that was called the War of Independence that actually took care of not having the Queen of the United States. So this is the same situation here. OSPF 1 and OSPF 2, think of them as the United States and England, right? Even though the language is technically speaking the same, there are very, very different laws and different regulations. And the laws in England cannot be compared with those laws in the United States, even though some of them are probably the same. I guess don't steal is one of them. I don't think it's legal to steal unless you are high income banker. In that case, I guess that's just daily business for you. But in this case, the metrics cannot be compared. So what can be compared? Well, what we can compare is the original admin distance. Well, the problem there is that the original admin distance is exactly the same. So this also won't help us make a determination. Now, this is where the consistency of iOS strikes again. For OSPF, if you are using OSPF as a routing protocol, and if you have this situation that you're learning the same route from two OSPF processes, what is going to be the situation here is that the route learned first wins. This is also true for ISIS, which you don't really care about, but I think it's fun to mention it. For EIGRP though, route from, now this is where I always forget. So let's test this. It is going to be the route from either the lower autonomous system or the higher autonomous system. But you know what? And this illustrates the point. You know, I know so many things about network. There are things that I don't know about networking. There are many, many things I don't know. And there are things that I simply cannot remember, no matter how many times I try them. So every time I'm in a situation that I have a doubt about something, I am actually going to lab it up. Good news is that I actually have the lab that I can easily do that on. So this is the setup that I have right now. So let me add another router. So I'm going to add R4 to the mix. And I'm going to, from R2, advertise, let's say 24.0.0.0/24 network. And from R4, I'm going to advertise 24.0.0.0/24. Now here, I'm going to run EIGRP 25, which incidentally is already running. And here, I'm going to run EIGRP 45. So I'm simply going to see which one of these two routes that are exactly the same will win on R5. Very, very simple test. So let me go to my terminal. I'm going to add back R4 to the mix. I already have, no, I actually deleted that interface, so let's configure it. So IP address 192.168.45.5. No, shutdown. And I may need to modify the process of EIGRP just a little bit. So I'm going to say network 192.168.25.0, no network 000, because I don't really want this process to run towards R4. So here I have it. Now let's create that other process. So router EIGRP 45, no auto summary. And you know what? I can just copy paste this and change this to 4, so this will take care of it. Now on R2, let me create interface loopback 24, IP address 24.0.0.255.255.0. That will advertise this interface on R5, so I can see it here, show IP route EIGRP. There it is. And let's go to R4. So on R4, I'm going to say router, let's create the interface loopback 24, IP address 24.0.0.255.0, router EIGRP 45, no auto summary. And here it's okay to actually run on all the interfaces. So now when I see the EIGRP neighbor come up, if I do show IP route EIGRP, I should be seeing, actually there is a loopback 0 here, so no interface loopback 0. Let me get rid of that one. So here I can see that the route from R2 is actually winning in the routing table. So if I go to interface serial 020 and I shut it down, here I see that one from R4 is now in the routing table. So remember, this process here has the higher value than this process here. So it has the it's the higher AS value. So if I bring that interface down, no shutdown, when the interface comes up, there it is, and EIGRP, I can see that R5 now prefers the route from R2. So to answer my own question, my own doubt here, it will be the route from the lower EIGRP AS number. Now, while I'm at actually proving how things work, let's see this one in action here as well. Again, a very, very simple test. I'm going to use the exact same network, so I'm going to have R2, R5, and R4. Here, I'm going to have 24.0.0.0/24. Same thing, 24.0.0.0/24. And let's run OSPF 25 here, and let's run OSPF 45 here. So pretty much the same setup I have right now. I just have to change the routing protocol from EIGRP to OSPF. So no router EIGRP 25. I'm going to say router OSPF 25 network area 0. On R4, no router EIGRP 45, router OSPF 45 network area 0. On R5, no router EIGRP 25, no router EIGRP 45, and router OSPF 25 network 192.168.25.0 area 0. And I will have OSPF 45 with the network 45. So now I can see that both of these processes have loaded. So show IP OSPF interface is brief. I just want to see that I do actually have neighbors, so I can see that different processes are running on these two interfaces, and I can see that I have adjacent neighbors. So if I do show IP route OSPF, I will see, sorry, loopback interfaces. Apologies, there is an extra thing that needs to be done there. And I will talk about this, so apologies, I just forgot that I need to do this. Otherwise, they will be advertised as /32s, and in that case, they're not the same route. So here, now I see that from R2 was the route that I'm preferring. So now what I'm going to do is I'm going to go on R2, and I'm actually going to shut down the interface between R2 and R5. So now R5 is actually going to be preferring the route from R4. If I do no shutdown on the interface, and when OSPF converges, there we go, change state to up, it's changed from loading to full. Let's give it 10 more seconds. I will see that I'm still preferring the route from R4. Why? Because it was the older route. Now, if this route disappears, so interface serial 010 shutdown, now R5 will actually prefer the route to R2. As you can see, R2 is now the route in the routing table. Now, when this interface comes back up, and when R4 advertises the route again, this route here is going to be considered the older route because it was learned first. So you can see that this one is still in the routing table. So OSPF prefers the older route to newer route in a case that you have this tiebreaker. This is very important because OSPF prefers stability to lower AS number that EIGRP does. But this is actually a very dangerous situation because at this point, when these routes are received from R2 and R4, when they need to be installed in the routing table of R5, there is no, differentiation between the internal route and the external route in OSPF. To illustrate this, what I'm going to do now is I'm going to go to R4 and I'm going to say in the OSPF configuration, so router OSPF, this was 45. Instead of run this on all networks, what I'm going to do is I'm going to get a little bit more specific. So 192.168.45.0. Like so, and I'm going to remove this network statement here. So this is the configuration now on my R4, and then in the router OSPF process, I'm going to say redistribute connected subnets. So now on R5, this is the route that is preferred. Mind you, this is the route from R2 and is an OSPF, it's an OSPF internal route. I can see that by O here. If I go to R2, interface serial 020, and I shut this down, on R5, what I'm going to have now, maybe I need to do interface serial 010, no shutdown. Maybe the interface was shut down, show IP OSPF neighbors. Nope, it wasn't. So let me see, why am I not redistributing? Let me see, redistribute connected subnets. Why am I not redistributing this? Should have been redistributed, but it wasn't. So router OSPF. Did I configure the wrong process? Yes, I was. Oh, Jesus. Okay, let me fix this. So I'm going to say redistribute connected subnets and autopilot in the fingers. Router OSPF 1. Very, very dangerous if you're using non-1 process. You'll be configuring wrong stuff. Anyways, now I do have the external route on R5. Now, we know that OSPF prefers internal over external routes, but what's important here is admin distance 110. So now, let's bring that interface up on R2. So now R2 is going to be advertising internal route. Take a look at which route is in a routing table. It is the external route. Now, this is exactly what I was saying before. At this point of comparison, when R5 needs to choose between this process and this process, it doesn't matter whether the route was internal or external or the other way around. What matters is only the admin distance. This is 110, this is 110. If this is not comparable, we are going to go for the original admin distance, which is going to be 110 here, and the original admin distance here of 110. If this is the same, as it is the same, we go for the oldest route. And in this case, the oldest route is the route from here, which happens to be the external OSPF route inside this OSPF 45 process. But this doesn't matter anymore. Here, I have in the routing table OSPF external route which is preferred over an internal route? Well, internal route from another process. And remember, England, United States. Internal here means nothing, internal here. The only thing that matters is the admin distance. So the question here was, what happens if I clear IP route? Okay, let's do clear IP route star and see what happens. This one wins. Why did it win? Well, because at that time, what happened was, when I clear the IP route from the routing table, the routing table is going to go to the processes, OSPF on one side and OSPF on the other side, and it's going to ask them, hey, give me your routes. And this is an iOS internal process, and it could happen that it asks the process towards R2 first, because in this case it has the lower process number. So in this case, this might be a situation. And let's test that example as well. So here, what I'm going to do, I'm going to remove the OSPF process 25, and I'm going to create OSPF process 250 that is going to have the exact same configuration. So you asked me the question that made me really, really curious. I don't know answer to this one. So that was my educated guess at this point. So show IP route OSPF. Now the external one is the older one because I removed the process. But if I do clear IP OSPF process star, clear IP route star. Now the routing table now goes for the route to the routing processes, telling them, hey, give me your best routes. So if I do show IP route OSPF, well, it looks like the internal in this case wins. So the answer is, I really don't know at this point what could be the cause of this. But you know what? You made me so curious that I'm actually going to go and try to find the answer. Now, the good place to find the answer for this particular behavior would be, the book is called, I believe, iOS Internals. It's rather old, but it could answer this question. If the answer is not there, I would have to grab someone from Cisco, hint, hint, if you are online, to use something called Topic to answer this question for me. The Topic is Cisco's internal corporate brain, where the information could be found. But this particular behavior here, to be honest, I expected the external route to pop in here, but let me try one more thing. Let me try one more thing. Let me try one more thing. Just want to try this. It was a very, very good question. Now, the internal still wins in this case. Very curious. As I said, don't know the answer to this particular one, but I would have to research it. But if you don't clear the routes, the behavior that I explained is there. The OSPF does care about the internal, external, and inter-area routes great deal, but the routing table doesn't. So there is no route preemption, but it could be that if they happen to arrive at the same time, and a clear IP route would be one of those situations when they arrive at the exact same time, that the preference could be given to the internal route from the process. But as I said, at this point, it's just wild guessing on my behalf. I would actually have to go and read it. This is something I don't know the answer to. You caught me there, and you have it on camera. So this is a very, very good question.